Push record. Hey everyone, welcome to the first inaugural episode of AI Cube. My name's Alan, a startup investor and founder. And I did my MBA at Berkeley, and I have my partner in crime here, Albert.
Hey everyone, my name's Albert. I am a, senior product manager at Amazon. Spent some time in Alexa on their self-learning team, and now I'm on AWS. So also did my MBA at Berkeley. Excited to be here.
So each week we want to talk about the latest news around AI and talk about analysis and impacts to the environment. So with that said, in this week's episode, we want to have a Google-oriented episode because obviously a lot has come out, being Gemini 2.0, and how it compares to O1, Claude, Llama, Grok, so on, and some of the applications that it's building around Astra, Mariner, and then finally the new quantum chipset Google has created here. So with that said, let's kick off by talking about Gemini 2.0. So do you want to give a quick overview of Gemini 2.0, Albert?
I'd rather leave that to you.
Okay,
I
sure
think
thing.
as the Amazon employee here, I can. First of all, I'm offended that we didn't talk about Amazon Nova, but I will defer that to you.
Yeah, so today Google has just released their latest foundational model, Gemini 2.0, and this competes obviously with a lot of the existing models in the market, such as O1, Claude from Anthropic, Grok from XAI, Llama from Meta, Amazon Nova from Amazon, and so on and so forth. So we have all these hyperscalers investing incredible amounts of money into training and building their own models. And so it comes to a point where like what actually differentiates all these different models, because effectively a lot of them are all training on, the world's data in a way. So the potentially in the short term is a minor advantage when it comes to the different data sets that is trained on. But one thing that's quite unique about the Gemini model is actually the token window. So Gemini has a million token window compared to O1, and at least O1 preview right now only has 120K token window. And so what a token window is, it allows you to add information into your prompt in order to better contextualize that prompt for the model to give essentially the best answer possible. So with that said, because Gemini has this 1 million token window, it means that you can effectively put in more and more information. So you could upload like PDFs, books, like whatever documents and files at a larger scale to give you a better, more contextual answer. So with that said, Albert, how do you see some of these different model competition playing out?
Yeah, I think from a foundational model standpoint, it's certainly interesting in terms of the competition and in terms of how the different hyperscalers and the model owners are trying to differentiate themselves. I know that OpenAI, for instance, with their O1 model, has pushed more recently towards reasoning. That's what they've been trying to do with O1 Preview and the latest O1 Pro, I think that they announced recently as well. So they're trying to move more in the reasoning realm. But I think we are at a point where, and I'm going to be a little bit of a contrarian here, but with all the excitement about foundational models, I think the marginal improvement from a customer experience standpoint is is increasringly uh is shrinking. And so what I mean by that is, when the ChatGPT came out, GPT 3.5, people were amazed by what it could do, right? It could write poems, it could, you can give it natural language, it would be able to interpret. 4 got better in terms of the types of responses, in terms of the complexity of the responses. But we're at a point where it's nearing or exceeding what humans are able to put out, depending on the application. And so it comes to what is next and why do we need a better foundational model, right? Like, why do we need a larger context window? And so I think that that's the interesting piece because foundational models will continue to expand and grow and get better and better and better. But unless those applications for, whatever those marginal improvements are, it's a lot of money hyperscalers are spending to create these models. I'm curious to understand what is that next, what is next for foundational models that, is going to excite people? Are we going to reach AGI? Is that what's going to happen? Or, with LLM architecture, is that not a point we're going to reach? Curious about your thoughts.
Well, I think that's an interesting point. Like, okay, let's put us in the position of a hyperscaler. Let's just say Google as an example, right? If you don't have your own foundational model and you're reliant on, let's say, another party's foundational model for the applications that you build, there could be a scenario where you might get locked out of that model. It's just like if OpenAI, if effectively almost similar to what Apple's doing with some of their Apple Intelligence, if you're reliant on a third party provider to power your AI applications moving forward, there could be a day where the model's not good enough, or they lock you out, or they have too much negotiating power. And in that scenario, if you don't own your foundational model, it really prevents or puts at risk a lot of the applications that you have. But also by having your own foundational model, it gives you more flexibility potentially in terms of some of the apps that you want to build on top of it. And I think where the world's moving toward right now is these hyperscalers, yes, they have their own foundational models. Yes, they have the APIs that developers can use, but more so they're building their own consumer applications for specific use cases that sit on top of their foundational model. And I think by having that, it gives them certainty and potentially more flexibility around building some of these apps moving forward.
I think that's a very interesting point. And one thing I'm curious about your thoughts on it as well is, I think your point about how all the different hyperscalers are creating foundational models that they aren't locked out. I think that's very fair, right? If let's say I'm a startup, I go and I build my entire business around GPT, and all of a sudden OpenAI says, you know what? You're gonna have to pay, $2 million a year to use this model. That could kill my startup, right? But I think what's interesting is Meta and Mark Zuckerberg's approach to AI is to open source that. The Llama models are out there in the open. Anyone with enough computing power is able to go host, and so that's where a lot of startups are emerging. Where they're trying to take and like for instance, they're using Llama to power some of what they're doing. So for instance, like AI startups. So I guess it's a similar name to X's Grok, but I believe Grok is the startup that does on memory uses on memory models, like it loads its models into memory to provide really really fast responses. And I think they're probably building their business model around using Llama because A, that's the open source model that they can host and run on their own infrastructure. Versus if I'm looking at Gemini, if I'm looking at O1, if I'm looking at Amazon Nova, even I can't host that on my own infrastructure. I have to rely and be beholden to Amazon, AWS, or Google, GCP, or Microsoft Azure, right? Like I don't have the computing power to do that. But if I wanted to do something like that, the only option out there is Llama. And the fact that there is an option out there means that foundational models are going to be out there for people. And so I guess the question is, if I'm a hyperscaler like Google investing billions into Gemini 2.0, what do I do better than the free version that Meta is offering?
But but again, right, you are tied back to Meta's investment into Llama in the long term as well. And Meta is a for-profit company. They could turn an open source project private at some point as well. So that that a risk that potentially is a risk that plays through. Um, but having said that, do you want to share some insight on some of the chip spending around the hyperscalers spend in terms to train some of these models and some of the impacts that you're seeing?
Yeah, yeah, and I think the story of the day, of course, is NVIDIA, right? Everyone knows how much the hyperscalers are investing into NVIDIA chips. I think Amazon, and I'm not saying this as an Amazon employee, I'm seeing this from the news article I read 10 minutes ago, but Amazon's put $20 billion into NVIDIA chips, just to be able to power to power models on Amazon Bedrock and all of that. I think there are two things that are really interesting here. The first is one, we're seeing a lot of AI spend. We're seeing a lot of spend on data centers right now, and I think that that's an area that Oracle's actually been entering the game in. Oracle has been building like newer data centers compared to AWS and Azure, which have a few more traditional data centers. And so what that means is Oracle's data centers are best for running AI models. And so the fact that is because of all this AI demand, there's the opportunity to buy new chips and build your own data centers and capture that market. So I think that's very interesting. But the second piece is there's also been an emerging need for custom chips as well. And so when we're looking about the $20 billion that Amazon spends on NVIDIA chips, Amazon's also spending $2 billion on Marvell chips as well. And so Marvell is creating, it's working with hyperscalers like Google and Amazon and Microsoft to develop custom chips that are much more efficient. So if I'm a hyperscaler and I'm Google, I'm building, Gemini 2.0, it's expensive to power that on NVIDIA. And to your earlier point, it's expensive to be beholden to one company. So I think it's interesting that, all this IT spending is going towards potentially building new chips to be more cost efficient and support that strategy of being a hyperscaler.
Yeah, I think as a AI advocate and like just observations wise, it's exciting time just to see every couple weeks, every day in some instances, punch for punch, Anthropic releases computer use. O1 comes out, then Google comes out with Gemini 2.0, Grok's building a chain of, you know, uh huge clusters around AI training as well. So it's just fascinating to see the amount of investment that's involved. With that said, with all this investment, there needs to be some type of return around AI, and the investment in return, of course, comes back down to the use cases and application layer of these AI models. And so, sticking to the theme of Google, Google's come out with two or three very interesting use cases. And I think Google's strategy is there'll be a path where developers will use their API to build their own applications. There'll be a set of users that use Google's, interface to ask questions or its Colab notebook to build their own tools. But I think there will be another layer of use cases which will be using Google's specific AI apps for different use cases. So there's three that I want to cover today. The first one is Jules. So Jules, you could think of it as, the GitHub Copilot coding assistant that can help it solve problems. So I think for this one, there's potentially not much different, at least on the surface. It probably comes down to how good the model is at up updating the code. The next one is Astra, which you can think of it as your daily AI assistant, where in this example that you're seeing on screen, someone can open up their camera and it can answer questions about the context that you're in. But I think what's the really interesting use case here is actually around Project Mariner. So Project Mariner is similar to Anthropic's computer use, where effectively it allows a user uh, to use an agent to take control of the browser in order to do work for them. So Project Mariner sits as a Chrome extension. And so in this specific example here, you have a Google Sheet where you've got a list of companies, and using Project Mariner, the agent will then go in, do a Google search on each of these different companies, extract their website, and extract their email address. So you could think of it as like an agent that can help you effectively book flights. You could ask it, find me the cheapest flights for these specific dates to these two locations and give me the best one across all these different comparison websites. Or you could ask it to plan you or to order you food from DoorDash. I feel like Thai food, I want it in less than thirty minutes, and I want it ideally under this 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 price here. And it will go ahead and do this. Like there's several other use cases that are really interesting, but I'll pause there and let Albert share his thoughts on this.
Yeah. First of all, yeah, I 100% agree. I think Project Mariner is, it's very exciting to see, how it can apply and how people will be using it. I think what's most interesting about it is I think the concept of it is basically reinforcing what these models are really, really good at, which is interpreting that natural language. And so I think what Project Mariner does is it's essentially the way that you look at it is it's a natural language interface for what the groundwork that was laid by robotic process automation. So before this, I think like 5, 10 years ago, the big thing was like RPA technology by UiPath, which is where people can go define workflows and say, I want a bot that's going to go, fill out my expense report, or I want a bot that's going to go book a flight for me. And the hardest part of that is having to go actually define the rules for that, right? I have to say, okay, you go to the Google Flights website. If you see the price that's over $50 or under, $100 and it's one stop or whatever, then continue and then click this button and click this button, right? So it takes time for people to define and create those workflows. But what this does is this offers a natural language way for companies and customers to basically create those types of bots really quickly. And I think, and I'm looking at this from, I know you provide a lot of very useful consumer lens use cases. I'm looking at it from an IT enterprise standpoint because ultimately everything turns into B2B SaaS in some way. But like the way that enterprises are really interested in this is there's been a lot of money spent on RPA in the past, and it's failed to live up to its hype. But something like this, making it easy and democratizing for every user to be their own admin and create their own automations, I think businesses are salivating at that. And I think there was a Gartner study that was done this year of executives that said I think over 70% of executives are planning to invest in generative AI capabilities, 17% in the next 6 months. And specifically, I think what's also interesting is a lot of companies are interested in looking into third-party solutions in an industry that's traditionally, very vendor locked, right? I'm using SAP, I'm using Oracle, I won't switch. But now Gen AI offers that use case for AI startups to break in. So I think it's changing
Yeah.
times.
I think even beyond that, right? Anyone that sold enterprise software into large corporates, there's integration costs into the spaghetti infrastructure that these large companies have. There is, the security compliance aspects. There's the upskilling, comms, handover, transformation piece as well, in order to get people to using these new applications. The hidden power of all this, I think, is the fact that it's accessed from a browser, which means any cloud app or any type of application that can be accessed through a browser can immediately be augmented and to have computer use or Project Mariner to be able to update and augment that. And even beyond that, it democratizes, all these automations to everyone. The interface is a natural language. Whether let's say a risk analyst, I can ask it to uh, you know, take this data, combine it with some data over here, write a report that assesses this into a RAG, like red, amber, green, and then write a report off the back of that. Or if I'm a finance analyst trying to analyze information, it just allows anyone to effectively, access and augment data from almost any application, especially if it's from a browser.
Yeah. I would be interested on the security implications of that though. Like if I'm
That
using
is
a,
true.
Oracle Fusion ERP, my financial information, my private financial information is accessible in the browser. Someone uses Project Mariner. Does Google get my financial numbers? Do they know my transactions? It's very
True.
interesting to think about.
But it's a same scenario here around Azure, right? So Azure has a private instance of OpenAI where effectively, it's a private instance, so your data isn't shared with OpenAI. It doesn't leave the organization's private cloud server. So I'd imagine Google with GCP might have a similar application moving forward where it's a private instance, let's
Yeah,
say.
that could be a way for Google to differentiate Gemini 2.0 and GCP with applications like this, as opposed to just foundational capabilities like Azure.
Yeah, and the thing is, with these applications, imagine across like a 50,000, 100,000 organization, if everyone had this tool within their interface and they could start augmenting data from the internet, from multiple, let's say you've got three or four different browsers open, each with a different application, and you need to combine that information into a spreadsheet that you're going to put into a presentation. You could have the four tabs open with these four apps, write a prompt that says, gather me this specific information from these four tabs and write it into a PowerPoint presentation. And then you will effectively save hours and hours of work. Which also actually presents probably another opportunity for Microsoft actually as well, because they have strong distribution when it comes down to their Office suite. So this is actually probably a good lead for Google, but presumably Microsoft is working on a similar thing.
Yeah, and I think I mean not to I gotta champion Amazon, but I mean Anthropic's Claude, I think they also released a similar capability in terms of being able to browse the web. And so I think as we started the conversation on foundational models, being neck and neck, I imagine OpenAI is going to have the exact same thing, and Microsoft will be able to offer the same services. I think this will right now this is really cool. It gives Google the lead, but I imagine this is going to be
Yeah.
everyone's going to have this in a year.
Yeah. And I think the broader implications on the startup community, like the hyperscalers are building such good generalized AI agents for apps. So the challenging part is how do how do startups compete in this environment where sometimes these generalized apps are just good enough where you don't need a specific vertical AI product. So it is a challenging one, and it's going to be interesting to see how this one plays out over time.
Absolutely. Yeah.
Um, With that said, our last piece is Trillium TPU, which is also called Willow, I believe, which is Google's quantum chips. Now, quantum is an area that I personally do not know a lot about, so I'm going to ask Albert a few questions here about what it is, why is it important, and what are the implications around it. So, with that said, I'll hand over to you, Albert.
Yeah, absolutely. So I can start with my rudimentary understanding of quantum. I will first say I'm not a quantum expert. I am someone that's just read articles on the internet. But that being said, I think what's really exciting about quantum is it presents the next paradigm of computing. And that's a very loaded statement and a very broad statement, but let me explain. I think where quantum is very good is at solving problems that usually take a very long time to solve because they're sequential, but you're able to break it apart. So, like, imagine a maze, right? The way that let's say you're trying to navigate a corn maze, and autumn just ended, so it's very topical. But you walk into the start, you walk, you reach a fork in the road, you turn right, you walk to the end. Oh, it's a dead end. You turn around, you go back. And eventually you will bumble your way through the corn maze to get to the end. And that'll be a good like 30 minutes, an hour or so. But now imagine if in that same corn maze, when you reach a fork in the road, you can go down both paths at the same time. You can go left and you can go right. Now, the one that goes right, obviously, is going to hit the dead end, but you're not losing any time because the you that's going left has found the right way. And so essentially, you're able to solve that maze problem really, really quickly. And so this creates all sorts of opportunities in those segments where I think the world has assumed that there are going to be some problems that are very hard to solve because they take a lot of time. Like, for instance, RSA encryption. That's a very common example where right now people brute force it because you have to try so many different combinations to get it. And so that's why people assume RSA is safe because unless you have the right answer, it will take you a really, really, really long time to find the answer. And so where Willow is, demonstrating Google's capability is they came out with a announcement a couple days ago where they solved a problem that would take 10 septillion years if it was done using traditional computing. 10 septillion years, I'm not making up a number, it's a 10 to the power of 25. That many years, it solved it in 5 minutes. And so that's very impressive in and of itself. Now that problem is not a very common problem. I don't think most people are trying to solve that on a daily basis. So, in terms of why this matters, it's still very early in terms of the technology and in terms of the use cases, kind of similar to AI. But what this shows is the future of computing, the assumptions that we make about how hard problems are going to be. I think that's going to fall away. And I think, like one of the good use cases we can think about is AI, because right now AI is a probabilistic model, right? It's a stochastic parrot. It's using probability to estimate what is the next best thing to say. And it's trained on a lot of data. But imagine instead of trying to predict what's the next thing to say, like it's able to evaluate in parallel what will happen if it says all of these different things, and then based on the potential responses and predictions there, it folds it back in and says, okay, this is the path, this is the response that creates the best desired outcome. I think that would be really, really interesting.
So just so I can understand it a bit better, maybe in machine learning terms, which is the unsexy component of, the AI umbrella right now. If you think about reinforcement learning models, maybe applied to the context of a game like Dota, where effectively, in order to blend the game and beat the pros, it plays Dota like over thousands of hours at a time, just constantly trying multiple different things to optimize to a certain outcome, to eventually, after, hours or weeks or months of training, get to the best outcome. Is what you're saying around Quantium, it allows you to just do effectively this training and all these different outcomes at an astonishing fast pace to get to that answer a lot quicker. Is that what
Yeah.
quantum is effectively? Yeah.
Essentially, and this is really reductionist, but you are doing all the possible combination like possibilities at the same time, and identifying what is the right path, right? And again, I will caveat, like this is not universally how it works. This is very specific to specific types of problems, where that's where it's currently found use. So again, like RSA is one. But just as a analogy, like I think that's a good way to put it, is you are considering all those different things. You know the outcomes. I think another analogy I really liked is the Doctor Strange and Endgame. Instead of him checking every single possibility, to find what's the one out of this 14 million, he's able to look at all 14 million at the same time and say, okay, well, this is the right one. And then maybe he could looked at, another 14 million and found, possible other universe where things could have gone better. So, yeah, I think that's a good way to think about it.
So, what's your outlook for quantum chips?
I think it's still early days, but I know like this is an area where a lot of folks are investing. I think right now it's too early to say who's going to be a winner and who's going to be a loser. There are companies that are investing heavily in quantum, like of course Google, and there's a number of startups doing so as well. I imagine Nvidia also has its own quantum research as well, because I think quantum processing units (QPUs) is going to be a completely different architecture than GPUs, different technology, different hardware to make that happen. And so right now it's still more of a research project, but I think as the research advances, as the technology matures, we're going to reach a point where it begins to get to someone's going to come up with what is that killer use case. Hopefully, it's not cracking RSA encryption because that is going to put the world in a lot of hurt. But hopefully, it's a beneficial use case or something people find interesting like ChatGPT, and then that's going to kick off the arms race there. So it's still very early. I know we're all focused on AI right now, but I think Google's doing the right thing and investing in the future as well.
Yeah, so it's interesting time. Jensen Huang from NVIDIA talks about CPU upgrades to GPUs. And now even before the GPU upgrades, we're talking about TPUs. So it's certainly an interesting time that we live in right now. With that said,
Absolutely.
thanks so much for listening in to our first episode of AI Cubed. I appreciate if you have any comments that you want to add or questions to us, and thank you for listening.
Hi, everyone.
Bye. I will stop recording.